So the first half of the semester, we are going to focus on how to design the database from the information. So information can be any requirement for your daily life, your company or business or whatever. Then we'd like to build a database system. To do that, we need to design something, which means design. In other words, we can say design. Database design means how to structure such a data. Okay, to make the data, because the computer can understand only the 0 or 1, the format, the structured information. So from the such information, so we start from our goal destination is build a database system using EMS software. Okay, that is running on the computer. Okay, then that's our goal. So we have such information, the requirement that we use the ER modeling, the entity relationship model, so that can formalize our information using entity and relationship like this one. Okay, that is called conceptual design, the logical database modeling or high-level database modeling. So we did such a entity relationship model, or sometimes the ER extended or enhanced ER modeling. Also, we have learned such a database model. For the database model, there are a bunch of different database model, network database model, hierarchical database model, and object-oriented database model, something database model. Among them, we select such a relational database model, which is based on the concept of relation. Relation means it's a set of data we regard data as a group. That is the convenient, efficient way to handle very large data, because we focus on we restrict using several constraints. The condition we can restrict the data, then we can easily, fastly search such a data. So we can finally using something database language that we are going to cover next week, we can create a database. Then this database system can serve for the server as a database source, data source, like the web server or your sometimes the user or sometimes the other application can access the database, okay, as a back-end database. So the missing part is here. If we can convert ER model to the relational schema diagram, then this whole designing process will be done, except the practical, the way of implementing database system. Okay, so last class we have talked about how to convert such an ER model to database model. We did the first step. So our goal is from this ER diagram to build such a relational schema diagram. This is our goal in chapter 9. So it's a very straightforward way. We can follow the step by step. So first step is what? Entity of the ER model will be relation. In other words, table. Okay. So like this one, what can be the relation and the entity, employee, department, and project. So we can create employee relation. We can use the key attribute to decide primary key. However, you should be careful. How many primary key? Only one. Okay. How many key attribute for entity? It can be many. Okay. For example, department has name is a key, and number is also key, but we cannot use both of them for the primary key. Okay. How can we decide? What is the criteria to select the primary key? It depends on application analysis. Depends on the requirement. Depends on many other aspects, performance and so on. Okay. By considering this one, it's you who decide what is the primary key. For example, in this case, employee is obvious because we have only one. So social security number. And the other, we can use it. What about the composite attribute? Composite attribute. Is there any way to represent the composite attribute in the relational model? Unfortunately, relational model does not allow such a composite attribute. Each value of the relational schema, it should be atomic. Okay, only one value is allowed in relational model. So we are not going to use this one. In case of composite, only the component will be each attribute. So for the first name, last name, middle name, initial, last name, and first name, and so on. Something like that. And also we can convert department. Department is the same thing. In this case, which one will be better, name or number? Both. Okay. Obviously, name will be unique, so it can be used for the primary key. But in terms of performance, number will be the better. Okay. Anyway, such a name probably the ASCII code. Then ASCII code should be converted. As that, it should be compared. It takes a longer time usually than the number. So we'd better use the number in this case for performance reasons. So we have used the D number and the other. Okay. And similarly, we can select the project. And in this case, it's the same thing. Project name or the project number, we'd like to select the project number, P number. And in this case, we can use the number as the name of attribute. Number as the name of attribute of the department. It doesn't matter, but it matters. It can be confusing, right? So to make sure which one is which, we can use containing the surface of the department, D number or the P number, something like that. There is no general way of the naming rule, okay? But if you join the real project, your project, whether your project manager would provide the naming rule for their project, okay? So you do better follow such a rule, but you can use the idea of the naming rule used in your object-oriented programming also, not very strict in database. Okay, so we can use it. That is a step one that we have discussed the last time. Also, in case of the weak entity, we have the one weak entity. The problem. Why don't you keep it? Yeah, why don't you keep it? So right now it's okay. Then a weak entity, we have the dependent. Dependent does not have the strong key. It has only partial key. So you, with the help of the identifying relationship, we can identify the specific dependent, the tuple, with the help of the key of the identified entity. So which means social security number plus name. Social security number plus name can be the primary key, composite primary key, and the other can be the attribute. That is the step 2. The next step, step 3 through the step 5, is for relationship. How many different types of the relationship we have? 3. 1 to 1, 1 to many, many to many, as you have learned in the set theory in your elementary school or middle school, even high school. So no matter where you learn, we have the 1 to 1, 1 to many, and many to many relationship. Okay, first we are going to deal with 1 to 1 relationship. First, 1 to many first. That's the easy one, easiest one. So 1 to many. How many 1 to many we have? Here, 1, 2, we already did, 3. 1 to many relationship. In case of 1 to many relationship, we can create, what is the 1 to many over here? It is the same structure as foreign key constraint in relational model, right? Relational database model. The third one is a referential intuitive, okay, constraint, which means it has a referencing and reference. So referencing, data in the referencing column should depend on the reference. It should exist in the reference. It's limited. Then we can keep the data consistency. It's a huge rule, okay? Huge restriction. Okay. Otherwise, unless we have the foreign key, we can create whatever we want. But for example, employee should work only this department, which means the department number of the employee should exist. So this one, we can just create the foreign key. Then we can add the column, referencing column to here. It can be the same name as this one. Doesn't have to be the same name. Sometimes the different name or simplified name is makes the user easy to understand such a relationship. Okay. However, be careful. The direction of the arrow is from many side to one side. I guarantee at least 1/3 of the student actually the other way. If I ask the foreign key in your midterm exam, okay, it's from. This is a reference one from here to here. Okay, referencing and reference this. Okay, n side and one side. What about this one? Control. Okay, project has the controlling department, D num. That should depend on this one, right? And one more, supervision relationship. So we have supervisor, SSN. This supervisor is also employee, right? So which means supervisor should exist in the employee, like this one. It's just a recursive. The relationship is a recursive foreign key. That's it. So that is one-to-many. In one-to-many relationship, so we can create the foreign key. The only thing you should be careful is the direction. Which one from which one? Okay, then one-to-one. We have one-to-one relationship. In case of one-to-one, what about this is a one-to-one mapping, right? From A to B. Which means we can actually merge it one, because they are one-to-one mapping, right? Does it make sense? Because it's a one-to-one mapping, you and you, like the couple. Think about the couple, boyfriend and girlfriend, or husband, wife. It's one-to-one. But I got the news last week. There might be possibility 3 parents. So anyway, that's the extreme case. So it's a one-to-one mapping, so we can combine. So to handle, there are different options to handle one-to-one mapping. In case of one-to-one mapping, we can merge into the relation. For example, if we have the employee and department, then we can have employee underbar department relationship. Then we can select either SSN or D number or D name as the key. Then add all attributes because it's a one-to-one mapping. Okay, but sometimes we do not have enough employee. Not all the employees are not the department manager, so some of the data will be known in case it's not. For example, here, if we have more, this is still one-to-one mapping, right? The one-to-one mapping does not require for all of this. As long as it's one-to-one, it's okay. So in case there is no matched one like this, you can put null data, all null data. Okay, that is first option. So we can merge into one. So option 1, merge. Second option is we can create, because employee, so 100 employee. Department, 2 department. So there are too many the null data. Okay, when we merge, at the time we can create in between table like the manager table. It has primary key of this one is the social security number plus D number plus, that's it. This is the primary key. Then add start date. Okay. Then we have employee. We have department. So this one is social security number and D number. Social security number both here. Department both here. Okay. Also, this start date move to either this one or this one also. Because it's one-to-one mapping. But in this case, we better keep start date in the in-between table. Okay. This is the second option. So we can create another relation with 2 foreign keys. Third one is, the second option is we create the in-between relation with 2 foreign keys. Last option is, because it's a one-to-one mapping, so we move all information to one side. It can be this side or it can be this side, right? Because it's a one-to-one mapping. So in this case, we move, because this part is like this, we can move all relationship to this side. Then we can create just a foreign key, like this one, employee and department. It has the manager, SSN. Okay? Then it has the start date. Not on the back. Just this. Okay? The last option is we add just a foreign key. In this example, which one is the best choice? Third one, because I used that. It depends on, okay? Also, it depends on real. But in this case, we'd better use this one. Why? First, we have another relationship. So that's not possible to merge, right? Merge is not possible. However, if this information and this information are almost identical, there is no other relationship, only one-to-one mapping, you'd better merge, right? It's not a good idea to separate the section 1 or section 2. Both of them are the database course, then we can merge. Okay? So at that time, we can merge it. Option 2 is used for, also, for example, if there are a lot of transactions or application or program that access only manager information, not employee, not department, only manager information. At that time, you'd better create an in-between table. Otherwise, if this information is either this one, you need to access some other additional information. Okay? We will learn later when we learn the join operation. If we do not know what is a join, we don't have to worry about. We will see. So later we will see. When we access the data, sometimes we can get the most of the information from one table, one relation. Not always. Sometimes you need to access several others. However, when you access the different data source, different table, it requires a lot of computer research, which means it's slow. Okay? So This time, if we need to access the only this manager information allowed, we can make the something in between table only for manager. Okay? Otherwise, in general, many of the case one-to-one mapping is the folding. Okay? So like this one. So we can create. In this case, we will select the option 3 to handle the one-to-one mapping. So we do the one-to-one and one-to-many. The last one, step 5, is a many-to-many relationship. So did you attend the last exercise lab for the Arwin software? So do you remember what if when you create the many-to-many relationship, what happened? Anyone realize? If you right-click the many-to-many relationship, there might be option to propagate. Okay? What happens if we select that option? It will create another table, right? So if you create the employee, and if you create the project, and many-to-many relationship, there might be, if you right-click this one, there might be option whether you are going to create another table. Then automatically 2 folding keys are created. Why? Why? What is a many-to-many relationship? Many-to-many relationship is like this, like this. Using relationship, you don't know which one is which. Because it's a many-to-many. One-to-many is okay. From many side, you can refer one side. However, this one is combination of one-to-many, one-to-many. Okay? You don't know which one is. For another, in this example, employee works for project, many projects. And each project has many employees. So for that many-to-many relationship, we can keep the number of hours. Okay? To identify the number of hours, you need to know only social security number? No, because he's working for several projects. Project A, 10 hours. Project B, 20 hours. Project 3, 10 hours. To identify the specific number of hours, we should know his employee, the social security number plus project ID. Okay? Then project A and social security number, then I can identify his number of hours for specific project. Okay? So that information can be included in this, just like the second option. We can create the table relation for this and this. Why? The ER model can keep, because it's a high level. It's a conceptual level. In the conceptual level, it's okay. However, in practical implementation in relational database, we should know this hour is for what. Because it's a many-to-many, using only employee, no, we cannot identify. Using the only project number, we cannot identify. We should know both this one, this. So that is the reason we need to create the in-between table. The primary key of this one is combination of this one and this. So social security number and P number. Then social security number left for this, and project number left for this, and all additional information will be added like this. So in case of the, why don't you, if you don't try yet, why don't you try using ERMA, Arwin software. Create the two entity and create a many-to-many relationship and right-click. Then there are options whether you propagate to the in-between table with the 240. So in this case, it is a work one. Social security number, P number, is a composite primary key, and hours, this one goes to this, P number project goes to this one. values up to the step 5. And next step is, so we deal with the most of them except this. What is this? It's a multi-valued one. Unfortunately, relational database model, in terms of relational database model, each value should be atomic. Okay? Only one value is possible. Somebody may be curious. Like for example, so for the location, what about this one? New York, Dallas. If you type the New York, Dallas, that doesn't mean this is two values. It's in the one quotation. It's just considered as the one single value. It's an alternate value. The relational database model allows only one value always. Okay? That is the simple way to access the data. If there are many possibilities, we don't know which one is which. Okay? So relational model allows the single value, unlike the ER modeling, so we cannot handle such a multi-valued one. Instead, to address that problem, we can create another table, DPT location. Like this. So, what is the key of the location? At least to identify the location of the department, we should know what? The department. Okay? Plus location name. Okay? And then D name. Location name. LOC name. Or city name is also possible, whatever. Okay? Then DNO. Where's the DNO? Yes. Therefore, this one. Because of this, actually, when you once you complete your project, actually you expect the 10 tables, but the result of your database sometimes 20, 30. Okay, because of such a very small table. Sometimes this kind of a table is called code table. 1, 2, 3. What does that mean? 1, 2, 3. 1 is for something HR. 2 is for something payroll. 1 is for manufacturer. So explain details about that. So like the location, department location can be one separate table. Okay? So this is a multi-value. That's it. It's done. Let's see the result. So we have the employee, okay, and we have the department. We have the department location, we have the project, we have work zone, we have the dependent, like this one. Then using this, in the next week, we can create the database using software, DBMS software. So we are going to use the Oracle database to create it. Any question? It's just a straightforward, but definitely need practice. So I think that we have the homework, so you can practice with the homework. That is a little bit challenging, not easy. Okay, so because it has a couple of more steps for enhanced extended part. Before that, this is a summary of such a step. Entity is a relation or table. 1 to 1, there are 3 options. One is merge, because it's 1 to 1. Or we can separate and create the in-between table and appropriate the foreign key. So third option is we can create the foreign key, just like the 1 to many. Which one is better? We don't know, but depending on the situation or application analysis or your decision, the database requirement, you can select one of them. But mostly one, like the 1 to many, it is the foreign. Many to many relationship, we can create the in between, the relationship table, in between table, then 2 additional foreign key. And the simple attribute, it can be the attribute or column of the relational model. Composite, we can create the component. For each component will be the attribute or the column. And multi-value, we can create the additional relation with a foreign key. And key attribute, among the key attribute, one of them will be primary key. Okay? And the other key attribute will be secondary key later. Also, it's called the candidate key. We will see the importance of the candidate key also later when we are learning the normalization. So normalization means so we can make such an initial output of the database modeling better and better through the normalization process. We will discuss after midterm exam probably. Okay, then I think that we didn't discuss about the n-array relationship. N-array relationship is this one. In case 3 or more the entities are involved, that is an array. This is a ternary relationship. In this case, how can we convert this one into relational model? So do you remember that? So when we understand such a ternary relationship, we can, one of the way is create entity and create the 3 one-to-many relationship. Okay? We can use this approach to convert into relational model. So we can create the supply, the relationship, the relationship table, in this case a supply. Then for primary key of this, we can borrow this S name, supplier name, part number, and project name, and composite primary. Don't forget to create the 3 foreign keys. What about the 4? 4 of them are involved. Same thing. We can create the foreign key and add. Sometimes, because it's too long, the primary key, so we can intentionally replace this composite primary key as simple, the number, okay? Sequential number or unique number, like the sequence. The supplier sequence, then assign 1 to 3 instead of such a composite key for better performance. However, at that time, you may lose some semantic information about the primary key. However, it's good for performance. Think about comparing such a number rather than the text information. Definitely, this one is fast. Okay, that is the reason. If you see the existing database, there are so many the sequence number or something sequence, something number. They love to use just a simple number or to make the unique, the primary. Okay. So that is the ternary relationship. Okay. Then we did most of the stuff except entity enhanced part. What is the enhanced year?
Extended ER.
Extended year? What is that? It has super class and subclasses. So in case we have the super and D or D subclasses. Anyway, this is one entity, right? How many entities? One entity. But it has the super and subclasses relationship. There are different options to handle this because we cannot convert this directly using one of this one. Okay? So first option is we will consider each class, superclass, subclass as a relation table. including super and sub classes. In this case, how many relations? 1, 2, 3, 4. 4 tables will be created. Okay. Second option is one relation for only subclass classes. So in this case, how many? 1, 2, 3. 3 tables will be created. I will show you the example. Option 3 is only one relation. For all of this, only one relation, but with type. I will explain that such a type. Last option is only one relation with yes or no. But in the same, what does that mean? With the example, I will explain. So for the example, let's use this one. So how many entities for this? 4. So only one entity, one employee. How many subclass? One subclass. How many subclass? One subclass. How many subclasses? 3 subclasses. But all of these were employed. So in this case, let's say this is a disjoint. Okay? Disjoint means employee should be either secretary, technician, engineer, or it can be just employee without this one because it's a single lane.
It's partial.
If the full, it should be one of this. Something like that. I want you to keep your mind this. Okay, then first option, using first option, why don't we convert to this one? So one relation for each, the class. Okay, so we can create the employee. We can create secretary. We can create technician. We can create engineer. Okay? Then, what is the key of employee? Social security number. What is the key of secretary? It's also social security number. Why? All attributes of the superclass will be inherited to the subclasses. So which means secretary also has a social security number, birth date, address, job type, and name. Right? So it has the first name, middle name initial, last name, DOB, address, job type. And this one also has social security number. Do we need to copy all of this?
No.
Actually not. Instead, we can just create a foreign key. Then using this foreign key, we can find all of this information. Then only typing speed. Typing speed only for the secretary, right? What about the technician? Same thing. Social security number, we don't have to inherit all of this. Instead, foreign key. Then T grade, technician grade. What about the engineer type? Same thing. Engineer type. That's it. That is the first option. Okay. What about the second option? Second option, only subclasses. Okay. So we do not have the employee. Okay. Instead, inherit all information. First name, middle name initial, last name, DOB, address, job type. Same thing. First name, middle name initial, last name, DOB, same thing. Copy this. Do we need any foreign key? They are independent this time. Okay? There is no relationship. Okay. So this is another option. Okay. Somebody may be curious. What's the main difference? What's the difference? First option and second option.
There's no superclass.
So no superclass, which means if you believe in your database and in your application analysis, if this one is not important, only most of the program access secretary separately, technician separately, engineer separately, then you can select second option. Okay. Otherwise, if the application program access sometimes general employee information, sometimes specific secretary information, sometimes specific T grade or the technician information, then you can select first option. So it depends. But many of the case, the first option will be selected. Many of the case. Why? If this one is not needed, you don't have to generalize during the conceptual model. Yes?
So let's say that we have a total disjointness. So then the first option will not be available, right?
The disjoint case?
Yeah,
Yes.
the total.
Total?
Yeah.
Oh, yes.
Double lines.
Right.
We
That's a
can-
good question. Which means, what if this is the partial participant? Which means there might be employee over here,
Yes.
right? So we need to keep employee information. So it should be the first option. And also, what about overlap? Overlap, you can select the second option, right? However, same information will be here secretary and technician. Worst case, all to be table. Can you keep the consistency? Yes, if you manually check every time. So if it is not easy, at that time, if you create the employee first option, you can update only general information over here, then for it. That is the main difference. That's a good question. Okay? So when you decide which one is the needed. However, sometimes we don't access a lot for separate information. Also, it's just one column, one column, one column. Why don't we combine into one employee? Because all of these are employee information. So, third option is we can create only one table, employee. Social security number, primary key, first name, middle name, initial, last name, DOB, address, and type. It has a job type. So job type is either secretary, technician, and engineer. Okay? So it has typing speed and technician, T grade, and engineer type. So for example, 111, the J Lee is the secretary, so job type is the secretary. Okay? At that time, I have the typing speed, so 10 words per minute. One of the worst. It was very important when I graduated from some of my colleagues, my classmates, they tried to get the certificate how fast to type to get a better job. But nowadays, nobody cares. Everybody cares about with your finger how fast you type. Anyway, typing speed is a 10. And what about the other, technician and engineer? We don't have such a data. It can be null and null. So what about 112? Is James Smith, and it's a technician, null. Okay, T grade is the project manager. Okay, the other, no, something like that. Okay. However, this one, because of the type of job, only one of subclass you can represent, right? So in case the D is feasible, however, what about the overlap? You cannot show both of them. To address that one, the last option is you can create same employee table, social security number, and same information up to this one. Instead of the type of job, type of the subclass, you can ask each of subclass, secretary, yes or no. Technician, yes or no. Engineer, yes or no. What is the type of this one? It's a Boolean. Yes, Boolean. Yes or no. Or true or false. So for example, social security number 111. So for example, I'm both the secretary and technician and the engineer, which means secretary, yes. And this one is the typing speed, 100. Technician, yes. So then T grade is high. And engineer type is a mechanical engineer. Yes? Mechanical engineer, something like that. Okay? In case of overlap, this one is better. Right? So you can select 1, 2, 3, 4. One of the 4 options. The most frequently used one. This one is used a lot. And also either this one or this, especially the type. Overlap is not usually happen, not many cases, but sometimes happens. So this one or this one. This is the best way to keep the consistency and to keep all the information. However, in terms of performance, this is not better than the one table. Think about I have the big classes, so I separate into 2 rooms. Whenever I have an announcement, I need to announce 2 times here and go to there, right? Instead, if I keep all the students in one room, all the data in one table, that should be faster, right? It's the same thing. So actually, it's kind of trade-off. So you may realize later, through such a process from ER model, and relational model, finally we can have the relational databases. So fast to manage the very large data. Why? Because we apply too many constraints, conditions. Separate, and we keep the consistency. So data is very, very clear. Clear means no garbage data. It's updated every time. However, because of that, when you access the data, you need to access the student information here, then you need to access the teacher information there. It's not easy to combine 2 tables, which is called the join operation later. So join operation is slow and slow. So sometimes if you consider the performance, you can combine into 1 table. That is to handle ER model, supine subclass. Don't forget we should have this, the foreign key in the first option. And this is the 3rd option, using type of job type, we can convert the super subclasses to here. And this is the last option using, it doesn't matter whether this is a yes or no, whether this time it used the flag, okay? We have flag or something flag information. What about the multiple inheritance? So multiple inheritance is the same thing. You can select one of the options, one of the 4 options. Why don't you take a look at this example? So this is the university database, the ER model for the university database. First, you should be able to understand this diagram. How many entities can you find here?
1. It's 1.
It's only 1, right? So, but when we create the table, when we create the database, it can be one or more the table or relation because of the step by step. So here we try to convert this one into the relational model. This is one of the example. This time we try to understand how it can be converted, how they are converted into this one. First, why don't you take a look at how many super and subclasses can you find? One, okay, two, three, four is a multiple inheritance, five, okay? One, two, three, four, five super and subclasses relationship. For example, this one is subclass of this one, but it's also superclass of this. Can be possible. It's an extreme case. So in real project, you cannot see such a case frequently. However, this is a possible case, so we need to handle